So let us start off with the first one. Before the collision, this is a particle A, this is a particle B, and the mass of these particles are also given. If I could scroll down, I can show you the mass of each particle is 1.67 into 10 to the power minus 27 kilograms. This is mass of not only A, but also the mass of the B, minus 27 kilograms. Calculate the total initial momentum of A and B. So total initial momentum would be momentum of A plus the momentum of B. And what is the momentum of A? The mass of A times the velocity of A. And what is the momentum of B? 0. Should have been the momentum of mass of B times the velocity of B. But the fact of the matter is, object B is at rest. It's not even moving. Its momentum would be 0. So you don't have to write the mass and then multiply by 0. Just write 0 straight away. But what is the momentum of A? This is the value of mass. This is the value of speed. Just multiply these two. And someone please uh, turn on the calculator. We'll be needing that times 500. 500 meter per second is the speed. So what do we get for the first part?
Sorry, can
Uh,
you please lower your screen?
okay. It should be there. I don't know why is it stuck. Let me share again. I Someone has commented, can I show the full? I can show you the full question right now. I had to show the calculation. You can download the worksheet from Google Classroom, the most recent post.
Sir,
So,
the answer is
hmm,
8.35 into 10 power negative 25.
okay, can I then write 8 point? You say at 8.35. So into SF, I can write 8.4 into 10 to the power.
25.
Okay, 10 to the power minus 25. So this is what we have for the first one. This is the momentum of A and the momentum of B before collision. And matter of fact, this is the total momentum before collision. So the total momentum before collision is the momentum of A only because the momentum of B was already 0. Now let's move on to the next part. Okay, explain what is meant by particles colliding elastically. There is no loss in kinetic energy of the particles. State an expression in terms of mVa/vb for the total momentum of A and B after the collision in the first part in the x direction. So find a momentum but in the x direction. So what do we do in that case? I don't have the velocity of A in x direction. It's not exactly in x direction. So what can be done? What is the tool that we use for these kind of situations?
Compass.
Vector component.
Exactly, the components, the rectangular component, perpendicular component, whatever you want to call that. So I'm going to draw components of VA and VB. So these are the two components for VA. Let me draw for VB also. Drawing them slightly at different places so you can see clearly. Otherwise, it'll be difficult for you. Now let us talk about the components of A. The one along the x direction should be VA
Cos 60.
cos 60. Very good. And the one along y-axis should subsequently be VA sin 60. Now for VB, the one along x direction would be
VB cos 30.
VB cos 30, and the one downward VB sin 30. So it was kind of easy. Now we have two velocities along x-axis. So we'll be having momentum of A along x-axis. How much would that be? Mass of A times, we don't have to insert the value of mass because the question reads, write the expression in terms of m, va and vb along y-axis. So that would be momentum of A plus momentum of B along x-axis and then along y-axis afterwards. So what is the momentum of A after the collision, means from this side along x-axis? It is the mass of A times the velocity of A along x-axis plus the mass of B, because they have same mass, so I'll write m with both of them, the velocity of B along x-axis. So this is the final expression for the total momentum after the collision along x-axis. So we can write it over here. In the next one, we need to state the expression for the total momentum in y direction. So momentum of A and momentum of B, but in this case in y direction along y-axis. So what is the momentum of A along y-axis? Mass
MVA
times,
sin 60.
yes, mva sin 60 plus
MVA sin 30.
vb. And there's a bit of a catch here. Momentum is a vector quantity. In the law of conservation of momentum, in order to find the total momentum, you have to use the sign convention for velocity also. Velocities to the right side should be taken as positive. The velocities to the left side would then be negative. So this is the sign convention. Velocity on the right side positive, upward positive, left side negative, downward negative. So according to this convention, VB should be negative. So what is the expression now? VA MVA sin 60 minus MVB sin 30. Alright, so 2 marks for this one, for momentum in 2D. And then you have a follow-up question for 3 marks. You need to calculate the magnitude of VA and VB, the velocities of A and B after the collision. So when we need to when we need to find the velocities after the collision, what do we use? We use the law of conservation of momentum. So momentum before collision would equal to the momentum after collision. But when you have momentum in 2D, means you have the velocities along x-axis as well as along y-axis. When you have momentum in 2D, then you use the law of conservation of momentum first along x-axis and then along y-axis. That's it. So let us use this law that initial momentum equals to final momentum, or momentum before collision equals to the momentum after collision, first along x-axis. So what was the momentum before collision along x-axis? It was mass of A times 500. And matter of fact, we can insert the value of mass, and we even have the value of the total value, which is 8.4 into 10 power minus 25. But I'm not writing that value for a time being. We can find the value afterwards. What is the final momentum or the momentum after collision along along x-axis? What was the expression again?
MV cos 60 plus cos 30. MV
Yes,
cos
this
30.
one. So just copy paste this one over there. MVA cos 60 plus MVB cos 30. So this is the first equation that you have. This is the equation along x-axis. So we can just secure it somewhere. Let me secure it at a safe place. Let's place it over there. Now let us write down the same equation for the law of conservation of momentum, but this time along y-axis. So initial momentum or the momentum before collision equals to the momentum after collision, but along y-axis. Now the biggest question is, what is the initial momentum along y-axis? Or what is the total momentum before collision along y-axis?
I guess 0.
It should be 0. And why is it 0? Because
Because
initially,
the object is not moving in the y-axis direction, it is moving in the x-axis direction before collision.
exactly, very good. You see, initially, these two objects, neither of the object was moving in y direction. I mean, B was not moving at all. B was not even moving in the first place. So forget about B. The entire velocity of A was in x direction. So the initial momentum in y direction is 0. And what was the total momentum after collision in y direction? We already wrote down the expression for that. Alright, so this is the second equation that we have. Let me bring it to the other side here. Now beyond this stage, it is entirely a question of mathematics. So I'm going to erase off extra stuff and I'll be left with two equations only. Can I simplify the first equation in a way that I can just cancel out the values of mass on both sides? Because first, in the equation number 1, you take mass common from the right side, and that common value of mass would be cancelled from the left side. So the simplified form of the first equation would be 500 equals this one. Meanwhile, I can cancel off mass in equation number 2 as well. How do we do that? Just take mass common from the right side in this one and shift it to the left side. 0 divided by mass would be 0. So this equation would be simplified as so these two are now the simplified equations. I'm going to raise off the extra ones. You can take a screenshot if you want because I'll be raising off the extra ones. So what do we do afterwards? We can insert the values of cos 60 and cos 30, sin 60 and sin 30. So 500 equals to cos 60 is 0.5, 0.5 VA, and cos 30 is 0.8667. Or you can write 0.867. Likewise, I can insert the values in the second equation also. Sin 60 is 0.867 VA minus 0.5 VB. So these are now the simplest equations that we have. I'll raise off the extra ones. Once again, if you want to take a screenshot, you can. Now it's purely a question of maths. I mean, you can think of it this way. 0.5 x here plus 0.867 y. So it is these are simultaneous equations. How do we solve this one? Which method do you find easiest?
Substitution method.
Yeah, substitute. I mean, elimination here would be difficult because the coefficient of VA and VB, these are not same. So first you have to make them same and then do the elimination. So substitution would be easier here. So what I'm going to do is I'll use the second equation and I'll find the value of VA in terms of VB from the second one. So the second equation can also be written as, and let's see if you agree or not, the second equation can also be written as this. Are we fine with it?
Yes, sir.
Okay. Now I can find the value of VA in terms of VB. So VA would be equal to 0.5 VB divided by 0.867. Now if someone can divide 0.5 by 0.867,
0.576.
so now we do have the value of VA. We don't have a numeric value first of all. I'm not saying we have a numeric value of VA. We do have, I should say, an expression of VA in terms of VB. What do we do now? We can insert this one in either of these two equations and then we can find the value of VB from there. So for example, VA equals to, I'm going to insert it in the first one. So 500 as it is equals 0.5, but instead of VA, I'm going to write this value. Plus everything else as it is. So if someone can multiply these two,
Zero point 0.288.
okay, 0.288 VB plus 0.867 VB. Now we have the like terms. We can easily sort it out.
1.155 VB.
And VB equals to 500 divided by answer.
$432.9.
Okay, thank you. 432.9 meter per second. We'll take care of the answer in the significant figure in the final answer afterwards. But let us find the value of VA now. We already have the value of VB. This is the first value that we have. But let us find the second value and then we can think about the SF and all that. So how do I find the value of VA? I simply insert this value in this equation. So what do we get?
$249.35.
Okay, 249.35. Now this is the second value that we have. Now if I take a look at the question, just to see how many SF do we have in the raw data. Yeah, so we have a minimum of 2. So I can leave the final answer in 2SF or 3SF is also fine, totally up to your choice. I'll leave the final one in 2SF. So the first one would be 430 meter per second, and the second one would be 250 meter per second. So 2SF would be fine, 3SF would also be fine, but never leave the answer in 1SF and never leave the answer beyond 4SF or not even in 4SF unless you have to. So this is the first step that should be done in these kind of questions. Whenever you have a question of momentum in 2D, the velocity would be given not only along x-axis but some place in the middle of x-axis and y-axis. You have to break down the velocities into two components. So the velocity was in the top right corner. The two components would be one at the top, one to the right corner. So one that is connected with the given angle theta would be 6 cos theta. The one that is connected with the angle goes with the cos. Likewise, the other one would be 6 sin theta. So for the blue ones, for the velocity, 3.5 meter per second, the component along x-axis is connected with the angle, with the given angle. So this one would be 3.5 times cos 30 because this angle is given, and the other one would be 3.5 times sine 30. Okay, so I might need to use these components, and matter of fact, whenever you have a question of momentum in 2 dimension, you'll most probably need to use these components. Okay, let's scroll down to the first part. By considering the components of the momentum at right angle to the direction of the initial path of A, calculate theta. Need to find the angle theta. By considering what components of momentum, we have two of those, one along x-axis, one along y-axis. But which one are they referring to? They're saying the one that is right angle to the direction of initial path. Right angle or perpendicular to the direction of the initial path. So they are asking us to consider the components of the vector along y-axis. Because the initial path was along x-axis, you see this is the initial path. The initial path is along x-axis, and they're saying consider the components right angle to the initial direction. So right angle to this one would be along y-axis. So we'll have to consider the components along y-axis. I can highlight those. One of that one would be this one, and the other one would be this one. So we need to consider these two components. So in these kind of situations, you have to use the law of conservation of momentum, first along x-axis and then along y-axis. In this question, they have specified that you don't have to consider the motion along x-axis. All you have to do is consider the motion along y-axis. So we'll use the principle of moment along y-axis, which is, we'll say the initial momentum or the total momentum before collision equals to the total momentum after the collision. In what direction? In y direction. So what is the situation before the collision? Well, before the collision, it looks something like this. And how do we know? You see, it is given on the diagram. The object is moving along x-axis. So if something is moving along x-axis, it has no momentum along y-axis. So initial momentum along y-axis is 0. This is what we get from the first part. Good job. Now let us find the total momentum after collision along y-axis. Okay, once again we have to use only y-axis because it is given in the question. I didn't say it is directly given in the question that you use y-axis, but this statement means you need to use y-axis motion only, because we have to stay right angle to the initial direction. Okay, anyway, what is the momentum after the collision? It would be the momentum of A plus the momentum of B. So do we have the value of masses? Mass of A is 4, mass of B is 12. So this one is 4 kg, 4 kilograms, and B is 12 kilograms. I mean, it's written over here. This is a mass, this is a velocity. This is a mass, and this is a velocity. So what is the momentum of A after the collision? Along y-axis, 4 times 6 sine theta. And the one that is vertically downward would now be taken as negative, because according to the sign convention, the velocities, this is the sign convention for velocities. Upward positive, to the right side positive, the one to the left side positive, and one to the bottom would be negative. So left and bottom is negative, upward and to the right side is positive. So the second momentum would be negative because the velocity is downward. So what is the mass? Mass is 12. And what is the velocity in y direction? Velocity is 3.5 sine 30. So this is the total momentum after the collision. So let me take it all the way over there. So 0 equals to that. So which value needs to be found out? We have only one missing value here, which needs to be found out, asked in the question, which is the value theta, the angle theta. Shouldn't be very much difficult. It is just a question of mathematics now. 0 here as it is. 6 4s are 24. Sine theta as it is. Minus 12 times 3.5 would be 42. And sine 30 is 0.5. You can do it on the calculator even. So 0 equals to 42 sine theta as it is minus 42 times 0.5 would be 21. Now minus 21 shifted to the other side would be plus 21 equals 24 sine theta as it is. So what do we have then? Sine theta equals 21 divided by 24, and then theta equals to sine inverse of this thing. 21 divided by 24. Can someone do this on the calculator? Sign inverse, then press the fraction symbol, and 21 divided by 24.
Sir, 61.04.
Okay, thank you, Ariba. So we have 61.04. So 61, we can go with 61 in 2SF. You can go with 3 also. 2 and 3, that's it. Never leave the answer to 1SF unless you have to. There are certain situations in which you have to leave the answer in 1SF. For example, the answer of absolute uncertainty. Other than that, 2 and 3 is the very safe option. So 61 degrees is the unknown angle. And also, once again, can be written as 61.0.